I wanted to kind of flesh out this problem for you. I saw there was another answer, a little hard to read when you have to type it. So I thought I'd show you how I did it, how I approach these identities. It can be a little bit tricky, but once you see some common ways of doing things, you'll be able to do these. So here I have the original equation just written out in fraction form, so it's easier to look at. And so here's what I thought when I first looked at this, because you have to make one side equal the other side, right? Okay, well, the thing I noticed is that on the right, you have two fractions, but on the left, you only have one. So my idea was to combine those two fractions. That doesn't mean that I knew for sure that it was going to get me to the left-hand side, but that's where I would start and see if I could figure out how to work it so it would equal the other side. So to do that, to get those two fractions to be one, you need a common denominator. So just like in arithmetic, I just multiplied the first fraction by the bottom of the other one. 1 plus sine alpha over 1 plus sine alpha. Remember, you have to do it top or bottom, or you change the equation. It wouldn't be the same. And then on the second one, I went 1 minus sine alpha over 1 minus sine alpha. And then the next line here, I just multiplied it out, the top. So I went 3 times 1, 3 times sine alpha, and that's where I got that from. And then the same on the other fraction. Then on the next line here, I combined them. Now check it out, because my 3 minus 3 sine alpha changed to negative 3 plus 3 sine alpha, because you have to distribute the negative to that 3 and the negative to the negative 3. And when I did that, it made it positive 3 sine alpha. I just wanted to be really clear and let you know what that was. Notice I haven't multiplied out the bottoms yet. I'm just dealing with the tops. Then the 3's canceled out. That was cool. And then I took the 3 sine alpha and the 3 sine alpha, and I added it up. And that gave me the 6 sine alpha. So now, even if I just stop here and look at the two sides, well, I at least now have the 6's right, don't I? So I have to make the rest be tangent alpha over cosine alpha. So here's what I looked for. On this bottom, whenever I see sine squared or cosine squared, I always think about the identities, the Pythagorean identities, and that the most common way we usually look at it is sine squared plus cosine squared equals 1. But I know I can rearrange that with algebra. It's legal. And so I solved that for 1 minus sine squared alpha. Oh, and that equaled cosine squared. Now, if I was you and I was doing this, I would write down all 3 ways of doing this Pythagorean identity, so you don't have to do the algebra every time. I've given you 2. The third one would be sine squared alpha equals 1 minus cosine squared alpha. Okay, so those are the identities. And now I'm going to replace 1 minus sine squared theta with cosine squared alpha. Sorry, I don't know why I changed the theta on you there. Okay, so now check it out. Now I have cosines on both of the bottoms, but I don't need cosine squared on the bottom on the right. So what I thought is I'd split up the fractions. So I made it sine alpha over cosine alpha right here. And then because I had an extra cosine alpha on the bottom, I wrote it as 1 over cosine alpha. Okay, then I thought, well, okay, but I know sine over cosine is tangent. So I replaced that, and that's good because I needed the tangent from over here, right? And then I just left 1 over cosine alpha alone. And then to get from here to here, I just multiplied the top. So 6 times tangent alpha times 1 gives me 6 tangent alpha. And the bottom gives me cosine alpha. And lo and behold, we have made them the same. So this may be overwhelming to you, but it's a common trick where you take 2 fractions and you try to make them 1. You just have to don't freak out that you've got trig stuff here. Just think about, I need a common denominator. I have to change the fractions, multiply them out on the top, and add them. And then from there, have your identities handy. Have your tangent equals sine over cosine handy. So you can just look at that sheet and try to look for something that's similar to what you have on your problem. Okay, Raylene, I hope this helped you. Good luck with these. I know you can get this done. If you need some more help, please look me up. I'd be happy to help you with this.